Hey guys, if you're planning to take the digital SAT this August, or if you're planning to take the exam September, we have some prediction videos for you. Before we get started, please note two things. One, you see the disclaimer listed here. And two, make sure to check out our playlist, specifically our SAT prediction videos. In the past, we have reviewed a ton of different SATs, and you can utilize those problems as extra practice for you. Now let's get started. So this is an interesting problem. They give you a function, they tell you it's defined this way, and then they say it could be rewritten in this form, and they let you know that there's a constant. And they want you to know what is the closest value of r, and you're expected to try to figure this out. Now, I want you to take a moment and think about this for a second. They give you two equations and how you can utilize this to figure out the value of r. And you might be thinking, oh my gosh, I don't know because I have the value of r and I have h of x. That's too many variables. The first thing I want to point out is let's change these h of x's to y's. And the other thing that I want to point out is if you are telling that one equation is similar or is exactly the same as another equation, and you were to graph them, can you remember what that means? Well, if they tell you it only is parallel, remember that is never going to intersect. If it's perpendicular, that it's going to intersect once, and that if it's exactly the same, it has infinitely many solutions. So that's my infinite symbol, and then the graph is probably going to look exactly the same, one on top of each other. So if we have infinitely many solutions, or the fact that they're the same exact, remember, they're going to basically superimpose on top of each other exactly the same. Okay, they're going to be the exact same line or structure or graph, whatever you see, which means that we can essentially graph both of these equations and check to see where they're going to be the same. So let's try that. First of all, remember we can't type in h of x, but we can replace it with y. So I'm going to go into Desmos and I'm going to say y equals 1.44 and then in parentheses here. Then I could use the caret symbol to fast track this. The caret symbol, by the way, is your little symbol that looks like an upside down V. It's usually above the number 6 button on your computer or laptop, so make sure you check that out. So the caret and then that's near 6, the symbol 6. You just have to shift and click it and then you'll see it. That's just a little shortcut so you don't have to go in and try to look for the exponent symbol in case you're looking to fast track that symbol for the digital SAT. So I'm going to go ahead and type that in for the x value there. So I have x there, and then it goes and it graphs that equation for me. And as you can see, it's like a designated little curve there. So let's try to now graph this second equation where we have y equals 1 plus r over 100 and parentheses, then take my caret symbol and place x again. Let's place x again. There we go. And then I'm going to add my slider. So my slider basically says I have one equation and I have graphed that where I only have one variable. But guess what? I have a second equation, and instead of one variable, I have two variables. I have my r and I have my x. And I want to know what my r is going to be, right? When the equations are exactly the same. Now I can go ahead and slide this little here, and notice it only goes so far. And if I go the other way, it goes so far. Well, if you notice, if I slide all the way to the right, I'm getting closer to it, but not quite yet. And I have my possible answers here. I'm going to chime in with 100 just to see quickly. And I realize that I've gone too far. You could see the graph here is a little bit too far to our original one. So I need a number less than that. So I'm going to try 44 here. So replace that 100 with 44. And if I go ahead and do it, you can see, let's see 43 here. So you can see it's slightly merging out. But if I do 44, it superimposes on one on top of each other. So that is the correct answer. And that's how we get answer choice B, or 44. If you wanted to double check to see the other answers to see if they're incorrect, you could see 14 here. It's too varied from that. Or if I type in 144, which is the answer D, too varied. So answer choice B is the best answer, 44, because it superimposes one on top of each other. So the best answer here is again B. Let's try to solve the following problem together. It asks you to find distinct solutions, which basically means that you have to figure out whether or not there is a solution at all. So to do so, we can use two ways of solving this problem. First, I'm going to show you the long way, and then I'm going to show you the short way. It says distinct real solutions in this problem. So you can go ahead and solve for this discriminant, which is the same thing as saying b squared minus 4ac. If you wanted to utilize this formula, which is the same thing as discriminant, understand that if you're going from highest exponent to least exponent, a is going to be 1, B is going to be 6, C is going to be 10. If you plug this all into Desmos and you solved, you would get -4, or even if you plugged it into your calculator. So you plugged in 6 squared minus 4 times 1 times 10. This will give you -4. Because it's a negative number, that's not a real solution. So we can deduce that the answer is going to be 0. There's also another easier way to solve. Let's try to figure that one out too. We can go into Desmos and we could type in our equation directly, where x squared plus 6x equal plus 10, and we can assume that equals 0. Basically, we're trying to see when it equals 0, which basically is a fancy way of saying when it crosses this x-axis here. As you can see here, if I go ahead and take a look at the graph that I graphed, you can see that it does not cross the x-axis at all, which is also validating our answer that it's 0. So that's the faster way to solve as well if you wanted to utilize Desmos. I also want to preface this by saying, let's take a look if we are going to have infinitely many solutions. That means it's going to cross infinitely. So the light green line there is meaning that it's going to cross that x-axis. If it's one solution, you'll see a graph that looks like a C where it crosses that x-axis once. If it's two solutions, that means that we would take this parabola, push it down just a little bit, and it would cross twice. So these are all going to be 2 times. So that's the faster way, basically, to find real solutions. You plug in the equation, assuming that it's equal to 0. You're basically saying, when does it cross the x-axis? You solve for that, and that is your answer.
Appreciate you riding along for our cosmic journey. If today's mission brought you the knowledge that slaps, make sure to hit that like button to boost that signal. Subscribe if you're locked in for our next launch. And don't miss the link tree. It's got all the goods for AP Bio, PSAT Math, and SAT Math. Before I sign out, make sure you're all in one orbit and diving in. Killing out. Till next time.